All right, so we are once again in the Grundfos booth. I'm here with Pete. We're going to have a look at some of the commercial offerings here. As you can see earlier, we were looking at residential product. Now we're into some really big pumps. And do you want to just walk us through what you've got set up here in the AHR show?
Absolutely, thank you. Basically what we're looking at is a primary secondary system, or at least done a little bit differently, and to ultimately optimize the chill water system. So what we're looking at here is this is a typical 3-pump or triplex primary pump set. These are Grundfos pumps. They're MBS model. They're split coupled, no alignment, silicon carbide seals, so very durable, robust design. Going to last a lot longer than a traditional end suction type pump in the application. This is a skid that we sort of engineered and built from the ground up. So it's a new modular base design that we're introducing here at ASHRAE. These are our MLE motors. So this is a pump integrated with a variable frequency drive, as well as onboard controllers, and then managed by our Grundfos MPC controller. So this is built for pressure boosting and hydronics.
So how many gallons a minute can these pumps actually move? Because these are significant pumps that you've got.
Oh, these are significant pumps. These are smaller ones for our demo here today that we'll show as we go through the system, but we'll have these up to 10-inch suction and discharge. Wow. So 3,000-4,000 gallons a minute.
Yeah, so that's quite significant.
Yes, absolutely.
Excellent. And so this is a pre-assembled skid that a contractor could just basically take this entire thing into the mechanical room and drop it into place?
Yep, plumb it up, electrical, done.
And does it include the braided connections as well, or
no,
does it kind of stop here?
It's sort of cut off flange to flange.
Awesome, and includes the integrated control.
Integrated controller and everything you see here. The difference in sort of what we do versus others is we pre-engineer these. So all these are sort of built out, ready to go. So what that allows us to do is move them through engineering really quickly, the factory really quickly, and offer basically the lead times that you'd expect on an individual pump, but with a system.
The advantage I see to this, and contractors and engineers sometimes need to be reminded of this, is that this is going to look costly, but the reality is the ability to take this into a school or a high-rise building, drop it in place, and in one day have this completed. That's something that I could do. And the reality is if I tried to build this, I could build this. But I'm going to be weeks doing so, and I don't have that finite control that you have at Grundfos, where you can assemble and design this for what we see here. Can you walk us through some of this piping here as well?
Exactly. So we've got a fully operational system. We're moving water, a glycol water mix, and like I said, here's our primary set. We come around to, we've got a bypass. So I said the industry has gone the route of variable primary, right? It's there's benefits to that, but it makes control difficult. So what we want to do is sort of utilize the same piping scheme that you would have. We have our bypass here. The significant thing that you would see that's different about our system versus others is it's not a controlled bypass. We're not putting a control device there to manage the flow through it. Our goal is to eliminate the flow through it, which is going to make sure that our secondary and our primary are hydraulically balanced.
That's surprising, because mostly everything that nowadays in the industry, everything's trying to connect. So it's interesting that you're doing kind of the opposite approach for this.
Right, and we are going to add some electronics to it when we get out to the distributed pumps, but each one, it's still a sort of a decentralized system. Each one manages its own terminal unit that it's assigned to, and it's hydraulically connected, so these two systems via our 4-temperature bypass will essentially know what each other is doing. They'll speed up and slow down, again, essentially to eliminate flow across the bypass, but really to satisfy those loads. So hydraulically connected, but no need for electronic connection. We don't even need to be hooked up to a building automation system if you don't want to. If you want to monitor and control and have that benefit, you can, but it's not a requirement.
What I like about this, Leah, with the decentralized, and I'm a big fan of decentralized, is if you ever had a problem using this system that Grundfos has designed, you're not going to lose the whole building. You might lose a section, and that's something you can easily deal with, whereas if you lose the entire building, doing it some of the, I'm going to call it the other way, you know, it can be a big challenge. A lot of people in the design systems, they don't think about what's happening in the real world of what happens when you have that Saturday night failure. I know when I design things, I'm very focused on when I get a call on Sunday, am I going to be dealing with 100 units that are without heat or 1,000 units that are without heat? It's very easy to replace that. It is not very easy to replace all of the stuff that you see here. So decentralized is key. So, what other controls are integrated here on some of these pumps that we see downstream here? Because these are really smart pumps that you guys have on the system, these Grundfos pumps.
They are. If we take a look at what we are calling distributed pumps, this is just an out-of-the-box circulator. It's our Magna 3. We rolled this out into the market in 2012, so it's very permanent, very proven design. It's a permanent magnet or ECM motor, so the most efficient motor you can get. All the controls are on board here. So all we're really doing, we haven't built anything new for this layout. All we're doing is applying our existing technology.
Well, that's kind of important, right? This is a good show for you to be able to bring your products and show people how you intend them to use your products. I know we sometimes get guilty of using the products in unintended ways, and I'm sure you learn stuff from us using things in unintended ways. What sort of flow capacities can this do?
So this will go up to about, in a single pump that you see there, about 300 gallons a minute.
Nice.
We do also sell this as a tandem, which will be out of around 550 gallons a minute, or two of these pumps would talk wirelessly. So if there was a redundancy thing or an increased flow that we wanted to do, we've got options on how to tackle it. But basically the key thing is here is that, you know, all the controls necessary to make this a distributed pump and provide that demand-driven performance that we're looking for here at the air handler is in the box. Everything is right there. So we've got a pump. You can't really see around the corner. There's a check valve because if one of these isn't calling, we don't want flow back through it. So, you know, we'll have that check valve there. But that's really it. So what we'll do essentially is no different than what you would do with the control valve. If you could imagine an air duct here, if we could have had that, we'd have an outgoing air temperature sensor, 4 to 20 or 0 to 10. We'd wire that directly back to the pump. All the inputs and outputs are there for it. And then we'd speed up and slow down to match the demand that we would have at this air handler. This pump will act independently of the next one and independently of everyone down the line.
So I would imagine that when I have the two of them tied together with the built-in logic that you have, that if I have one in duty standby, they'll know to rotate each other. And if I lose one, will it know that, okay, this pump has gone offline, but that one that was duty standby automatically kicks in and keeps the building going?
Absolutely. You got it. All that is there. It's really just same thing you'd get with an old alternating panel, but it's just all wireless and built into the pump. Just makes it easier.
And could a technician or a building owner remotely manage and see this equipment as well?
If they wanted to, yeah. Awesome. We've got what we call SIM cards or communication interface modules, and these cards snap right in here to the head of the pump, and we've got them in Bacmet, Profibus, LAN, a couple others I can't remember off the top of my head. And then the other option for communication here is with your phone.
Yes.
So these wirelessly or Bluetooth, we can communicate with our phone, and all of our commissioning is done right here. So if you've ever done any commissioning or been part of a project that required...
Quite a bit.
Yeah, I bet. Really all we're going to do is this pump is sized for the flow rate for the load. We picked the head to basically overcome the resistance that this pump will have for this load specifically. So we come out to the pump, we give it a set point, we enable what we call as flow limit, which essentially it's like a governor for the pump. So we tell the pump, a pump of course, we've sized it for 100 gallon a minute if that's what this particular load is. It's capable of pumping 140, 150 gallons a minute at the far right of its curve. We basically electronically tell the pump, you are a 100 gallon a minute pump. It will never pump a gallon a minute more than 100. So we've eliminated another reason for having that balancing device there. So now it's electronically commissioned for this particular air handling unit. No matter what happens, if you add down the line, if you have fouling in the coils within the terminal unit, the pump will adapt to that and always provide you the perfect flow at the right pressure. I
like that you're using Bluetooth. As somebody that used to do a lot of service install and now I'm on the design and training side, one of the things that really intimidates people is having to get in and set up controls. Like that is a completely separate division. That's not something HVAC contractors should be doing. The Bluetooth can be a little bit intimidating, but it's very easy. It doesn't require any sort of remote access. You just directly communicate with the pump and set it up, and I'm a big fan of that. It's a great way to go.
That's it. And all the systems that we've done so far have all sort of locally controlled, but we do monitoring via BMS building automation systems, and it's really easy to set up.
When were these introduced to the Canadian market?
Right around the same time as the U.S. That was, I think, pretty much a dual launch. So that was around, those pumps themselves around 2012, 2013.
Okay, so they've been around here for now for a while.
Yeah, they've been around for a while. Yep.
Is there any other functionality we may not have touched on? Some hidden secrets people should know?
No, that's really it. I mean, the whole idea is we're trying to make it simple. I mean, we're delivering next level control on chill water systems. We've got huge case savings stories that we're working on right now in our first installations here in North America. And that's it. You're trying to offer a simple but very effective solution.
Well, having walked around your booth with Leah and talked to your different team members, a lot of new people. I saw Barry, who I know quite well. I think you guys are well on track to do that. So definitely appreciate your time today, Pete.
Thank you very much. Appreciate it. Thank you, guys.